Hi, this is eman32x's tutorial on how to make a scale in Half-Life 2 with Garry's mod and Wiremod, PHX. First, you're going to need a couple parts to make the base structure. You'll need a wide base, I recommend the plastic, along with a 4x4 grid and a 2x1 grid. Of course, any parts work, but the large plastic is good. The actual beam of our balance is going to be a telephone pole found in useful construction props. You're going to want to first probably easy weld the small part to the top. This is where all of our circuitry is going to go and where the readout's going to be. It's where people are going to spend the most time. It doesn't need to be accurate, but if it's accurate, it looks a little bit nicer. Next comes the balance. The important thing about the balance is that one of the edges has to be flush against one of the edges of the pole, so it'll take a long time to make sure that it's flush. But just as long as it's flush, doesn't matter if it's to the left or to the right. I like making it square, but you don't need to worry about that. It doesn't worry about the height either. That was just convenient for me. It's just frozen in the air right now. In the moment we're going to pull up a tool, we're going to pull up the slider tool. And using the slider tool, we're going to attach the base to the pole. And the slider tool is going to make it so that the base can only slide straight up and down, and it can't float left or right or out to either side of the base. It can be a little bit difficult to get in there. I do recommend keeping it close to the base. You can maybe it was a little bit too close there, but I do recommend keeping it close simply because otherwise it can be a little bit more difficult to center objects, but it doesn't really matter. The slider's just gonna make sure that in relation to each other they only slide. I recommend no colliding all of the parts. There's no particular reason for this except it can be very finicky if it falls over and difficult to snap together. In fact, you're going to see that a little bit later on. Next, I like snapping the wide base on the bottom for the exact same reason. Everything should be frozen. This does not work if any of the parts are not frozen generally, but having a wide base at least makes it a little bit easier to write it again in case you do freeze it. I first went from the base to the pole. It's actually easier to go from the pole to the base. A lot easier to line up. That's called Snap Mod, I believe, or Snap Grid, the mod that brings up those crosses, by the way. If you've never been able to find it, it's definitely a must-have. And as you can see now, the base falls free. But there's nothing holding it up. It just falls straight to the ground, and that doesn't quite do it. So we're going to get the elastic tool in a moment and string up the top onto the base, onto the weighting platform. First I'm going to show you how a very heavy object just kind of makes it drop straight to the ground. We're going to use this heavy object later on. I like to use the washer. It's a very, very heavy item in the game. Not the heaviest, but among them. Okay, bring the base up very close to the top. The closer the better, but if you get too close it'll be very difficult to do two of the steps, so that's about enough right there. Get an elastic. You want to set it to a high elasticity. I recommend 1700 with a high dampening as well. I recommend about 50,000. Really, you can't go too high. String them up. You'll notice that it floats free. And if you push it down, it comes back up. And now, if you drop the washer machine on it, it falls about halfway, and then balances out and sticks in one spot. And that's going to be the basic mechanic of our scale. That could be it, but we're now going to use Wiremod to actually display some units for us, and so we can figure out what the weight of various items are. And I do say weight. It's important to remember that we don't know what gravity is in Half-Life, so we can't drive mass, but we can get weight just fine. We're going to place down some circuits. We're going to place down, that happened rather quickly, there's a jump there, a screen, a multiply, a subtract, a constant value, a ranger, and a D latch or edge latch, edge triggered latch. You're going to wire this up. I'm going to go over it again in a second here. Sorry that went so quickly. Oh, and a button to reset the screen. Now, the screen gets its value from the multiply. The multiply gets one of its values from the subtract. This multiply gets the other value from the constant. By the way, the constant is not set yet. We're going to set that constant later. You slap it down, but you're going to replace it in a little bit. The subtract gets its first value from the ranger, and its second value from the latch. It's important that it comes in that order. It is order sensitive because it's subtract. The latch gets its value from the ranger, and it gets its clock from the reset button. That reset button and latch, by the way, is going to make our tare. So as you can see, it falls. Remember to keep things frozen, folks, otherwise it'll get a little bit crazy. Okay, when you put it on, notice how when it comes back it's going to be at about 0.173. That's why the tare works there. Now, I got to remind you that the values we're actually seeing are incorrect because we haven't set that constant value yet. We're going to get back to that in a little bit. It's called our dampening constant, but it hasn't quite, or our elastic constant rather, not dampening. And we haven't figured it out for this scale yet. It's something that you have to figure out every time you make the scale. It's going to be around 1.4, which is what I have it set to. So first we're going to have to calibrate it. So to calibrate, what we're going to do is we're going to set down a series of thrusters and use them as our baseline. So first debug the ranger so that you get the ranger's value, because that's important. And lay down 7 thrusters, each of them at 1,000 thrust, and fire them off. I'm going to speed through that process very quickly here, but what you do is you create an XY scatter chart of the distance created by thrusters and the amount of thrust that you use total, and plot those. You're going to create, it's going to be a very linear line because it does work out as a linear line. The more thrust you add, the further down it goes in a linear comparison. And you want to get a trend line pointed at. I recommend using Excel. That trend line will be in the form of y equals mx plus b. You want to solve for x because x is the weight. B is going to be actually you want to set it yourself, and you want it to be the distance at rest. And then the most important thing then becomes m. You want to take the inverse of m, believe it or not. Take the inverse of m and make that your new constant value. Once you've set the inverse of m as your constant value, that's going to be your elastic constant. It's going to be something around 1.4, as I said earlier. In this case, it was 1.2 something. It's going to be different for every scale. And then once you've set that, you will have your dampening constant, and in fact, the scale will be done. So again, the way to do that is to use Excel to plot the distance that the amount of thrusters pushed it down versus the amount of thrust. Plot those on a line, add a trend line to those, edit the trend line so that you can specify your own intercept, make the intercept into the distance being read out by the ranger when there is no thrust, and then m, you just bring that to the -1, which is the same, or put it 1 over m, and that's what your constant should be. You can also just leave it 1 over m and change that multiply to a divide, and then it'll work fine. And then your scale is done. As you can see, 156 is actually an amount of kilothrust. That's I misspelled kilo. That's a little bit embarrassing. 156. A lot of very heavy objects have that same amount. You're going to see a couple other objects have 156. I should mention this is normalized at this point because we solved for our elastic content. No matter what scale you make, it's always going to come out to about the same. Also, I'm going to show you in a little bit now how, nothing's perfect. There's various forces. Also, the physics model isn't perfect, so there's a lot of error. That's why you want to re-tare every single time. And even then, even after you've tared, the entire scale seems to be accurate to plus or minus 1 kilothrust. Kilothrust, by the way, is our unit of weight, essentially. It's the amount of weight created by a force of 1,000 thrusters. And then this is a very useful unit. This is kind of the baseline almost. 1.5 barrels. Any barrel object in the game is 1.5 kilothrust. So you can almost just make things into barrels as the unit of weight. Tear after every time, and you'll get units, and you'll notice how even after just a single weight of the exact same object, if you pull it back up again, the tear is going to be off already by 2.5.